A determinant is a function whose inputs are square matrices and whose outputs are real numbers. At first, we'll avoid function notation when calculating a determinant and use a function machine instead to learn how to find the determinant of a square matrix. Let's input the 2 by 2 square matrix, row 1, 5, 2, and row 2, 8, 4, and see what the determinant function machine pops out. Looking at this function machine, we see that the determinant of the 2 by 2 matrix, 5, 2, 8, 4, is the product of the entries along the main diagonal, 5 times 4, minus the product of the entries along the minor diagonal, 2 times 8, which is 4. Did you notice the function notation we used here? We have the function name, det, or det, which is just like f in the function notation f of x. A left parenthesis, the input of the function, which is a square matrix, and a right parenthesis. From this function machine example, can you write a generalized rule for calculating the determinant of a 2 by 2 matrix? Well, the determinant of the 2 by 2 matrix A, B, C, D is the product of the main diagonal, A times D, minus the product of the minor diagonal, B times C. Or sometimes we get lazy and instead of using the det or det function notation for the determinant of a matrix, we just replace the square brackets around the entries of the matrix with straight bars, and this also represents the determinant of the matrix. So let's practice finding the determinant of a couple of 2 by 2 matrices. Find the determinant of the matrix -3, 4, -7, 5, and the determinant of the matrix 6, -3, 2, 3. Push pause and calculate both of these determinants. For example A, did you get -3 times 5, subtract 4 times -7, which equals 13? And for example B, did you get 6 times 3, subtract -3 times 2, which equals 24? In the next video, we learn about cofactors and how to find the determinant of an n by n matrix where n is greater than 2.